Buffers. Buffers are solutions that resist pH change. You think of how we use the word buffer in real life. A buffer is like a cushion or a dead zone between people who don't get along. It's a buffer, right? It cushions things. So a buffer in chemistry cushions the changes in the pH. The way a buffer works is it's got significant amounts of a weak acid and the conjugate base of that weak acid. So you've got both of those things in there. If base is added to that solution, the weak acid can neutralize it. If acid is added, the conjugate base can neutralize that acid. Okay? Your blood contains a buffer system that regulates the pH in your blood. Your blood needs to be between 7.36 and 7.40 in pH in order for you to be healthy. If the pH drops below 7.0, goes above 7.8, you die. Not good. But the buffer is there, and most of the time keeps your blood pH in the correct level. How do these work? Okay, acetate, sodium acetate buffer. Acetic acid is a weak acid. So here's acetic acid. It's got one ionizable hydrogen. We add sodium hydroxide. The acid donates its proton to the hydroxide, and we get sodium acetate and water. The acetic acid neutralizes the base. Great. In that buffer solution, we also have that conjugate base, the sodium acetate. Sodium acetate, when you add acid to it, will accept the proton and regenerate acetic acid. So both forms of it are there. If you throw in acid, the base takes care of it. If you throw base in, the acid takes care of it. And so it can maintain a pH that is close to what it was originally. It won't be perfect, but it'll minimize pH changes. Here's a picture form. So here we have our buffer solution. We've got significant amounts of the weak acid and its conjugate base, what happens after it's lost its proton. So we've got both of these present. Put hydrogen ions in there, they'll hook up with the conjugate base, get neutralized. If you add hydroxides in here, they'll take a hydrogen ion from the weak acid and get neutralized. So we can neutralize either way. We should be able to identify a buffer solution. Remember, you need a weak acid and the conjugate base. So let's look at A, H2SO4 and H2SO3. Do we have a conjugate acid and base here? No. A conjugate acid-base pair differ by one hydrogen. These both have the same number of hydrogen atoms. It's not a conjugate acid-base pair, so that's not going to work. Yeah, I don't know how that happens. How about HF and NAF? Yeah, so when these are aqueous, when this is aqueous, that is sodium ion and fluoride ion, right? When HF ionizes, it forms fluoride ion. Fluoride is the conjugate base of HF. Now the question is HF a strong acid or a weak acid? It's a weak acid. So chlorine, bromine, and iodine are strong acids, hydrochloric, hydrobromic, hydroiodic. But hydrofluoric, she's the little sister. She's not very strong. She's weak. So we have a weak acid and the conjugate base. This is a buffer. How about this one? HCl and NaCl. Is this the conjugate base of this acid? Yeah, it is. Because this is sodium and chloride ion. And when HCl ionizes, it forms chloride ion. So we do have a conjugate acid-base pair. Is this a weak acid or a strong acid? That's a strong acid. So this cannot function as a buffer because when HCl is put into water, it ionizes completely. It makes the hydronium ion and chloride ion, and this reaction only goes in one direction. It does not go in the reverse direction. So even if you've got significant amounts of chloride, when you add more acid in here, the chloride's going to like, I don't want anything to do with you. You're on your own. And the pH is going to change. How about this one, sodium chloride and sodium hydroxide? No, why not? Well, one's a base, one's a salt, but there's no acid at all. Neither of these start with H. So that's not. Any questions?